They will use it as they go to the introduction to see how the Metasploit work and stuff like that. So yeah, we'll get there.
It's an open source tool.
Yeah, it's an open source. Yeah, it's free tool.
Yeah, it's a free tool. But is there any other tools that you use here?
Yeah, like that.
More intrusive.
Yeah, TCP dump. TCP dump going up there. But Wireshark is what the industry use. So it's open source. It's a great tool.
Excellent tool.
Yeah, excellent tool.
Ethereal.
Yeah, Ethereal. Yeah, way back. But now they make it much easier so then you can see everything. But then as you go,
So what is how each layer of OSI? What is operating system? What is OSI? Like,
have you shown them the
OSI? Yeah. I'm going to go to that. I haven't got there yet.
He also knows.
Yeah. No, I'll get there. I just want to give you guys a few stuff here. So let's see what I have. Set a question.
Do you all understand the concept of what a packet is?
yeah.
You understand, right? It's information in between.
Yeah.
See?
Yeah, but a complete message might consist of 100 packets that have to be reassembled at the other end.
And sometimes you can also have bad packets.
Bad packets.
that you cannot do anything. Like some attacker interject.
Right, like for example, the source destination and the source and the destination could be spoofed
in the middle, by many
Right.
in the middle, and then that is why when you're doing malware reverse, right? Sometimes the attackers can send you to the wrong path, looking at the wrong thing. It usually happens to those guys who to the newbies, who's just trying to learn. But like the most experienced guys, they've seen it a lot. They automatically know that that's a spoof or a different path. Anyway, that the attacker can throw you off. That's the goal, because he sends you back. He's to the wrong way to investigate what is happening.
Yeah, he might be trying to also get information about your network. If he sends something in the wrong place and he gets a bad answer, then he goes, okay, that's not a good one. And then try another one.
Yeah.
Right?
So what is the underscore member you mentioned? So
the underscore member, right? It's just a text that shows up in the packet trace. When you do like a show me the trace in information, you get a bunch of information. So which you probably have like IP addresses and different
port
names.
Numbers.
Yeah, port numbers. But like the underscore member.
Would that be in the payload area that you're talking about?
Yeah. It will be in the packet. That's what it sends as soon as if you want to. Because that's what the attacker sends to see if your party server is vulnerable. If it is, then it will attack you.
Sure.
So what you do is you look for that particular text inside the payload of a packet, and if you see it, then you know that somebody's trying to attack you.
Yeah, then try to find out, and then what you do. So that person now will have a source IP.
Right. You'll catch that.
Then by the source IP, then you block it in your system.
So how do you know underscore member is not expected in the packet? You should know, right? But how do we know?
No, basically based on intelligence that comes through. The intelligence said if you see that string into the packet.
This is a theoretical case.
Yeah.
He's saying if you have somebody attacking you and you happen to notice that inside one of the packets coming from the attacker,
Unusual.
there's that text that says underscore member.
That's unusual. You shouldn't be seeing.
And that's unusual.
Yeah.
You shouldn't be seeing it, and then that's something unique that you can look for that will specifically identify
Yeah.
packets coming from that attacker.
from
Because he's using
attacker.
a certain kind of attack to try to open up your
Yeah.
network.
Yeah. So what does that do for you? That will prevent you to have false positives when like you write the filter to prevent it, or like at least to know where this thing is coming from. You see, when that Intel come with that vulnerability that has to do with the BIOS, like somebody can take over your laptop based on some setting in the BIOS, right?
They can implement a rootkit from the BIOS too.
If they can, if they have access to it. So that particular vulnerability use a high port, like a high number. I think they're like 20,000, something like that. A bunch of them. So now what you do, based on those port numbers, now you can write filters in like your SIM, filters in your IPS to block any communication. But you know, if you never activate that virtualization from Intel chip, and then you are fine. But like if you do, even though it built inside the chip, right? There's a network that interact with your main network.
Yeah,
that can cause you to be vulnerable.
A piece of that chip can actually be written to. It's on the boot ROMs.
On the boot ROM, yeah.
Yeah, there's a piece actually that's not read only, but you can actually write
execute it. Yeah. So that is why, you know, that is why in like security, even if you're doing pen testing, it's good to have a good understanding. Because why? Because the client at time will ask you certain questions, and then you can educate them, and then everything is available online. You know, it's just to do practice, and then you will be good at it. So the OSI layers that every device is trying to communicate to. So we are like 7 layers. The first layer, as you can see here, is the physical one. So when you're trying to build a network, you have a bunch of hardware devices on the ground, wires that you have to run. You know, so you can see the controllers, the network, the NIC card, the cables. All the stuff is at layer 1.
And our brains have an ESP controller that we can.
So that's what they call the physical layer. That requires some physical work to go and lay out the infrastructure. To bring the equipment in, to bring the wires in. That's layer 1. Now, layer 2. Once layer 1 is done, and then you go to layer 2, and that's why you have the data link. So this is where net packets now being translated into bits. And all those bits are on top of those physical layer here. Bunch of zeros and one. That's why when you have your MAC address, every device has a unique MAC address. You can block stuff on the MAC address. Every device has a unique. It's like your driver license. Unique.
Your credit card chips.
Yeah. You be the only one.
Oh, anyway.
So and then the IP address has to be unique. John cannot have the same IP address that I have
On the same network.
on the same network.
Of course, the layer 2 is not network aware anyway, so it only knows things on its own network.
Yeah. So that's why you see that all the zeros and ones, they are passing on the data link layer. That's the physical, and then all the 0 and 1 bits, they are transferring on this layer, which is the data link layer. Now, so that's a summary here. So it's a bunch of zeros and one that are passing on that particular physical layer here, and then all the MAC addresses, physical, data link is all the bits are being passing by, bunch of ones and zeros. Now the layer 3.
So is MACsec pretty popular? MACsec at layer 2, is it pretty popular?
Oh,
MACsec? MACsec?
MACsec, yeah, it's somewhat popular. So layer 3, right? It's data are being transmitting between the network devices that are attached on that network. So basically, it takes the logical address and trying to translate it into the physical. Basically, now it took the computer name here and tried to link it to the MAC address. So network, you have a bunch of from A to B, from B to C. So it's trying to route the information. So if you go on like the interview and then the actual on like the OSI layer, where will you put the network devices? Now you said layer 3.
So when I was talking earlier, we were talking about switches, being a layer 2 device, right? But there are some
Smart
network
switches.
aware switches, and they're called layer 3 switches.
Yeah, like in intelligent
Right.
switches. Yeah.
Right.
So layer 4, right? That's where you have the transport control protocol, right? That's where you have the TCP stuff are coming in. That's where you have the TLS, transport layer security. So you know that TLS 1.0 is bad, right?
Yeah.
So you don't have that you don't want to have that in your network, because if you do, you will fear, and then you will also feel lot of audit stuff, right?
PCI 1.
PCI, yeah,
Everything, and it's all.
yeah. So you have to make sure like that. It's not part of network. Although some communities still have it as they are trying to figure out are they going to deal with that. So,
But are the more recent versions of TLS acceptable to PCI?
Yeah, 1.2, 1.3.
1.2, 1.3. And then you can also use SSL.
Yeah, not SSL v3 though. SSL has some issues of its own as well. So
Right.
What is that, V3, is it?
Yeah, it's V3. I think there was an issue. It was being compromised at some point. So now like the threshold basically accept all the data from the session layer and try to break it into packets and send it to the network layer to go from point A to point B. So now a session, right? That's when you're trying to deal with Metasploit. When you're going to use our example, right? We will go from Metasploit and then we are going to hit Metasploitable, the other host. Now you'll be creating a session. You see? So when you create that session, now you will be on that destination machine. Meaning you will take over that machine. Meaning you can do whatever you want with that machine. Meaning you are root. You have full access. Meaning you own that company. You own that machine. Then so that is why, you know, so a session, right, is a connecting point between point A and point B, right? Mm-hmm. So point A is talking to point B. Now once I own point B, now point A becomes the owner of point B. He or she can do whatever he wants now. That is why I didn't want to go in show like Metasploit now until you guys go have a basic understanding of that concept. So we'll be operating at layer 5. So whenever you're trying to build the web to get some file from some other system, you like open a session between you and that system to get the information that you need. So layer 6, when I send an email, right? And then I'm going to open. I would look to understand what was sent. So there should be something called presentation. So basically, what the presentation layer does, it takes all the information that the email is going through, all those packets in information. It does like all the semantics. That's why in computer science there's a course called formal semantics. It's a great course, but it's trying to teach you the syntax, the language, you know. So that can make the computer understand what is happening behind the scene before it presents it. Like if you get it into an encrypted format, right? You and I cannot understand what the garbage is right there, right? Because it's all encrypted, right? But when it gets to the application, which is at the layer 7, now you will read the information. Why? It's because at layer 6, it does all the translation. Everything that is happening to show it to you. Every application you use, like FTP, like email type. They all are layer 7 applications.
And this is the layer, I think, where some filters work, right? Some content.
So some content filters work there, because if I'm blocking certain applications, yeah, you know, so that's where some content filter can work there. Yes.
Blocking certain kinds of images and stuff.
Images too. Yes, because all based on the application that are being used. Yeah. So.
Heard of WebSense?
WebSense. That's it.
Content filtering.
Content
Yeah.
filtering.
Yeah, actually, I did a lot of work when I was getting on who bought WebSense. I wrote a bunch of their content filters too. In there, there are some great tools. So you can see at this whole layer, like there are like 7 layers. So it's come from the bottom up, physical to all the way to the applications that you are using on your desktop here. Now we're going to do some Metasploit.
Yay.
So you guys been waiting for, eh?
Yes.
Metasploit.
It's good.
Because we're metasploitable.
Yeah.
So application layer is an internal. If you're working for a company, it's like an internal.
No, like when you check your Outlook email, it's an application layer. If you have FTP, secure FTP, it's an any application that you use
Okay.
is part of that layer. As long as it can connect to the network, you know. So yeah.
Because it said it provides a set of interfaces for applications. So.
Yeah. Because you know, like if I'm using FTP, like there's some software called WUFTP. That's an application. Then it has to do certain network connectivity, right? So that's what it does. So now.
So some quick questions. So
Mhm.
let's say I have a cell phone and I have 2 apps there, right?
Mm-hmm.
I have one app that connects to my thermostat, another app that connects to my e-lock, right?
Mhm.
But they're using 2 different networks. There is 2 different servers to connect to for the control and so on. So now if I take a look at this, my physical layer, I guess, is probably, it's the first immediate
Yes.
step is your,
Wi-Fi,
whatever you're using.
that we
Yeah.
have there, those Wi-Fi G devices.
Yeah, and then I go to my link layer, then you have my MAC layer, right?
Yeah.
So that is the address that I have here.
That's a URL
next one.
Bits 0 and 1.
Yeah. So, and now if I go to my transport layer, so I guess what I want to know is, I